Hi, I'm Walt Schulte. I'm an engineer at Agilent Technologies. Today I'm going to demonstrate a cost-effective solution for measuring wideband radar and SATCOM signals. To do this, we're going to use the PXA as a wideband down converter into our Infiniium oscilloscope using our N9030A vector signal analysis software. We're going to use a source to correct the amplitude flatness of the IF. Let's first set up our PXA. For this, I'm going to tune to the center frequency that I wish to analyze. So in this case, X band. Then I'm going to shift my IF higher from the normal 322.5 megahertz IF all the way up to 700 megahertz to take advantage of the full IF bandwidth. So I'm going to do this by creating a negative frequency offset of minus 377.5 megahertz. So now I've shifted my IF up to 700 megahertz. Then I'm going to come back over here and reset my center frequency to X band. From there, I'm going to stop the local oscillator from sweeping by pushing zero span. Then I'm going to bypass the preselector. So now I've bypassed the microwave preselector. And then I'm going to ensure that my wideband IF is on. Go down here to aux IF out, and then the second IF. Finally, I'm going to push single sweep to make sure that all the changes update. I've programmed my source for a center frequency of 10 gigahertz, sweeping 900 megahertz wide at a constant amplitude. Then I'm going to come over here and set up my vector signal analysis software for use with a down converter. So I'm going to go Input, User Correction. Then I'm going to check this frequency converter box right here. And then I'm going to enter in all the same parameters that I put in the PXA. So I have an RF center frequency of 10 gigahertz, an IF center frequency of 700 megahertz, just like I programmed over in on the PXA, and then 900 megahertz of IF bandwidth. And I'm going to invert my spectrum since we're high side mixing on the PXA. Now I have my source sweeping at X band, 900 megahertz wide at a constant amplitude, in this case 0 dBm. So in order to correct the amplitude flatness of the IF, I'm going to go in here into measurement setup, average, and I'm going to turn on continuous peak hold. You can see now that the source is sweeping across, and it's giving me a frequency response of my IF. So I'm going to let this run through several times. You see my source is sweeping along in about 20 seconds across the 900 megahertz. And once that I'm satisfied that it looks good, I'm going to go back in here into File, Copy Trace, and I'm going to copy this trace into Register D1. Once I've done that, I can apply the trace in Register D1 as a correction. So I'm going to go in here into Input, Fixed Equalization. I've applied Register D1 as a correction. And you'll notice here that the frequency response of the IF is now flat across the full bandwidth. So we can see here that on top I've got a center frequency of 10 gigahertz, and I'm using the PXA as my wideband down converter, and I'm in a span of 900 megahertz. On the bottom, I'm showing a time domain of my pulse sequence, and I've got a single pulse in view here, and I'm performing a gated FFT. That's what these two vertical lines are. I'm performing a gated FFT of a single pulse, and on top you can see the spectrum of the 900 megahertz chirp. This has been a demonstration of a cost-effective wideband analysis solution for measuring radar and satellite signals. For more information, visit the URL shown, where you'll find configuration information, option information, and an application note explaining this solution in greater detail. Thanks for watching.